and let me tell you it. By the way, I have finally gotten back on the horse. We have done weeks of the problem-solving techniques being so graphical. Slides are really hard for me to make. Now I'm going to be presenting to you some raw information, at least for the next 2.5 weeks. I've got stuff that could be put together in slides. So Merry Christmas. You may download, I think I called it slide set 4, the 4th slide set, the current slide set, the latest slide set on Canvas is this week's information. Okay, let's go into rotation. First off, let me admit that when I say rotation, I actually mean two things: circular motion and spin. Rotation properly is just talk about spinning. I'm sort of abusing terminology here. Here's rotating, and here's moving in a circle. Here's circular motion, right? You may have heard the rumor. Some people believe that the sun is the center of the solar system and the Earth goes around it. Yeah, have you heard this rumor? The Earth goes around the sun. The length of time that it takes the Earth to go around the sun, putatively, is 1 year. That's what causes the year. What about the day? What happens in the day? Princess Celestia raises the sun. The Earth spins once. Yeah. So there is a difference between spinning once per day and orbiting once per year. Spinning is rotation properly. Orbiting is circular motion. I'm going to describe both of these interchangeably. I'll give examples of rotation, then I'll give examples of circular motion, because the mathematics of these are virtually identical. Next class, the second half of this subject, we're going to be talking about something that only happens with circular motion, but everything today occurs in both. Okay, so we're going to focus on translation first, but I'll give examples of both left, right, and center. Circular motion is described by two terms. There's good old ordinary meters per second. You're going around in a circle. Or for spinning, you could talk about how a point on the edge of the circle is moving. The Earth is spinning, again, according to that rumor. The surface of the Earth, if you take a point on the surface of the Earth, we are moving. At the equator, it's like 1,000 miles an hour-ish, moving around as the Earth spins. Tangential speed is good old distance per time. Meters per second, miles per hour, whatever. There is a new term to describe the speed with which your angle changes, and that is given a very confusing, difficult name to remember. The speed of the angle is called angular speed. Big brain time here. Okay, angular speed, the letter for angular speed is not W. I won't dock your grade if you call it W, but I will hunt down and kill your pets. No, okay, maybe not. Angular speed, this is the Greek letter omega. This is lowercase omega. You may have seen capital omega is the horseshoe, lowercase omega, curly W on bottom. Okay, so angular speed or the vector quantity, angular velocity, there's an angular velocity as well, positive and negative, describes how fast an angle changes, as we see momentarily. First, a brief point or two about tangential speed. Again, I define tangential speed as the distance traveled by an object per unit time it takes. Question? Wait, tangential on what? Yeah. Nope. Nope. They're related, but they're not calculus derivatives. Okay. Tangential speed, again, is meters per second, distance per second. But we are not moving along a line anymore. We are moving around the circumference of a circle. That's why I prompted and started this lecture off by reminding y'all 2 pi r is the distance around a full circle. What happens if you don't go a full circle? What if you only go a quarter of a circle? What's the length of a quarter of a circle? 2 pi r divided by 4, yeah? What if you go over a 16th of a circle? Could you just do 2 pi r divided by 16? Hey, by the way, what's the angle of a quarter of a circle? In radians? Pi over 2? What's the angle of a full circle where you find the circumference? In radians, what's that angle? 2 pi, radians is one circle. 2 pi r. Get there in a second. I'm skipping ahead of myself. We'll talk about that in a second. Motion along the circular path lies on the circumference of the circle, and if you've got some fraction of the circumference, if you're talking about not a full cycle, well, whatever. Think about this for a second, my grasshoppers. Meditate upon this and achieve physics enlightenment. 2 race cars go around a track. Or, for that matter, you're going in an outer lane and there's someone turning on an inner lane. Who's going faster? Nope. If they're keeping pace with each other, if you're both turning the curve and staying side by side, the outer lane is going a bigger distance in that measure of time. 2 pi r, if r is bigger, 2 pi r is bigger. The length of the outside of a bigger circle is bigger. If you go a bigger distance in the same amount of time, turning right in the outer lane instead of turning right in the inner lane, you have to be going faster. This is why race car drivers jockey for the inner lane around turns. They try to drive carefully to be on the inner lane, because if they're going in the outer lane, they would have to be going faster. It's harder for their engines to do that. You will get around the curve faster. You will have achieved 90 degrees of turn faster if you're on the inner lane. It takes less time to go the same angle at a given speed. Okay, so think about this relationship. If you've got a bigger circle, you've got to go faster to make the same time. We're going to use this and make an equation out of this in a few minutes. So far, so good? So far, so nothing profoundly profound here? Great. Now here's angular speed, and actually I should be saying angular velocity. We're going to be talking about angular velocity in some of the homework problems, so let me describe that carefully later. Angular speed or angular velocity is the rate at which some angle changes. If I am spinning, it is the angle per second that I am turning at. If I am orbiting, if someone is standing at the inside watching me turn, it's how rapidly they're turning, how their angle with respect to time is changing. I'm going to give that example multiple times, so let me say it again. If you're a NASCAR cameraman standing at the center of the NASCAR track, actually, NASCAR isn't circular. Is there a circular racetrack? I don't know much about. A what? Okay, whatever. We're going to imagine that NASCAR is a circle, because otherwise the analogy breaks down. Assume that NASCAR is a circle. If you're the cameraman at the center, the angle, the degrees, the radians, the turns per second, various ways of measuring angle, the turns, whatever, how rapidly you have to turn is angular velocity. Hey, what's an RPM meter, a tachometer in a car? You know, the vroom vroom meter, not the speed, but the vroom. What does that measure? What's an RPM? Rotations per minute. What is that? A rotation is just one way of measuring a turn, an amount of turn, an angle. What's a minute? Well, that's a unit of time. RPM is nothing but angular velocity. Well, angular speed, they don't specify a direction. Okay, so the vroom of your motor is an RPM, a higher pitch. That's bigger angular speed. Question again. I mean, you could talk about the angular speed of the Earth orbiting the sun too. That's if you are the sun, how fast in angle do you have to turn to keep the Earth directly in front of you? That would be the angular speed of the orbit. If you are the Earth, that is in 24 hours, you go 360 degrees, 360 degrees, or the radians per whatever I'm going to talk about. Yeah. Good. Other questions? Okay. There is an equation. Here's your derivative. Angular velocity is defined as the rate, delta over delta t, of angle. That is to say, if I turn 5 degrees, and it takes me 1 second, my angular speed is 5 degrees per second. If I turn 5 degrees and it takes 10 seconds, my angular speed is 0.5 degrees per second. You take the how far you have turned or how far along a circle you have orbited and divide it by the time it takes, that's angular speed. It's not that profound, but I still get a lot of people saying distance over time for omega and angle over time for v. If you think about what angular speed means, the speed of the angle, not as hard as many people make it. Let's talk about signs here. I'm an Aquarius. No, angular signs. On a compass, which way is 0 degrees? North. Straight up. Do you guys use compasses? I mean, not like every day, but you spent any quality times with maps and compasses outside of your... But like, if you say 30 degrees on a compass, you know that that's pointing that way? Anyone been in Scouts? Yeah, okay. So old memories from elementary school age. Yeah, so in maps, we say 0 degrees is north, then we go clockwise around the map, clockwise around the, what do you call that? Clockwise around the compass circle? There's a word for that. And clockwise around the compass circle increases angle from 0 to 360. That's not the math convention. If you think about maps, don't. You need to know that that is not how we do. Clockwise is actually the negative angle direction. The math convention that we do in 10th grade or whatever is this is 0 degrees, x-axis is 0 degrees. And as we go counterclockwise, we go 30, 50, 100 degrees, whatever, right? You've all taken geometry in high school or something and know that this is 0 and it increases counterclockwise. Okay, so if a change from small value 0 to 30 is counterclockwise, that's the positive angular direction. If your angle is increasing, then delta angle is positive number, which means that omega is a positive number. If you're spinning or orbiting counterclockwise, that's a positive angular, I should say velocity. This is logically wrongo, because there is no such thing as a negative speed. If you are spinning, orbiting, whatever, clockwise, that's a negative sign. That's all just comes from the math convention of 0 degrees increasing. Still so far so good? You got the idea of angular speed as angle per time. You got the idea, or rather the convention of positive and negative direction of angles. Yeah? Great. Moving on. Here. I don't want you to just use an equation. I want you to think about what it means to go some number of meters. Here's Google question B. You should work with your classmates, and I haven't told you a formula to use. You have to think about the meaning of these terms and come up with steps to do it. There are at least a couple of ways to do this. The way I'm going to show you after you take a stab at it introduces a couple of terms. So don't zone out once done. There's important definitions that are coming in the process of doing this. Okay, carousel. By the way, I have had students struggle with this last year because they did not know what a carousel was. A carousel is a merry-go-round, a rotating circular platform with horsey statues on the end that you ride on. Whee! So the rotating carousel is 4.2 meters in radius. or at least one horsey is at 4.2 meters from the center. B, yes, Sabrine. B is for bees. They're in my eyes. And I will tell you that I'm estimating based on my memories of going to Phoenix Zoo last time. I think in 1 second the carousel rotates about 0.13 revolutions, about 8 seconds for one cycle. I challenge thee to find the tangential speed of the child on the horse. If the child jumps off the horse, how fast are they flying through the air at that instant? Ready, set, go. Work with each other, please. Juju question B. I'm looking for a number, by the way. You can tell me a number. Forget the equations. Use the ideas. Make the equation. I am the equation. B, Sabrine, is the numerical answer. I'm looking for a number of meters per second. I am challenging you not to just look up an equation, but to think about the meaning of each of these terms and figure out a way to figure it out. I will also remind y'all that 1 meter per second is about 2 miles per hour. And if you get a 500 miles per hour carousel, I think the parents will be mad. Please think about the order of magnitude of your answer. And again, if you get hundreds of meters per second, you done did it wrong. Or meters per second is 8. That's 90 miles an hour. That's 90 miles an hour. Actually, 100. Yeah. 2 miles an hour, roughly, per meter per second. Revolutions, cycles, turns. You go about an eighth of a turn each second, roughly. Oh my God, lots of correct answers. You're making me happy. By the way, 0.13 is not a number of degrees. Thou shalt not take sine or cosine of numbers at random. 0.13 tells how many cycles happen in 1 second. 0.13 of them. If you are confused and do not know how to get a final answer, I encourage you, in this as in everything, to take what you've got and think about what could I find based on what I've got? What could I find that I can interpret and know a meaning for? And also, what do I want and what would I need to get that? Then keep doing that until the two come together. And finally, ask your neighbor, because at least half the class has got this now.
Right, actually, I guess the wrong. Yeah, I know, but still, it's because I did it so often in chemistry, my first thought process.
Okay, 30 seconds. Give me your final answers. Almost 100 right. I'm pleased. Are there even 100 people in this room? Oh. Okay, I can't count. Respuesta correcta. The correct answer, the fraga, whatever, is 3.43 meters per second. About 7 miles an hour-ish. But the answer is not the most important thing here. I'm using this as a starting point to introduce some friends. Let's talk about that first term. What does 4.2 tell you? The radius. Does it tell you the distance that you go? You must think carefully about the path that is gone, the path that someone goes around when they're going around a circle, and do not simply take meters and seconds and divide. You don't go along a radius line from the outside to the center of the circle. Not unless the carousel designer is in big trouble. You go around the outside of the circle, the circumference. That's why we talk about 2 pi r. So 2 pi r and r have the same units. You cannot just divide without thinking. Sometimes I will give you circumference. Sometimes I will give you radius. Thou shalt think about what thou hast. 0.13 rev per. What does that tell you? What is a revolution per second, a cycle per second? What is that? What's his name? That's true. Percent of a circle. There's another way to talk about angle, really. We've got the degree, we got the radian, we got the cycle, we got the percent of a turn. I like it. What else? How else? Does anyone know the name of turns per second? This is frequency. I am defining frequency along the way in these slides. Write this down. Frequency, whose letter is, you'll never believe this, F, measured in hertz, whose abbreviation is 2 letters, HZ, capital H, lowercase z. I know that's difficult. I know it maybe hurts your head a little. You can do it. So frequency F measured in hertz, HZ. Hertz is nothing but cycles per second, turns per second, beats per second, something that happens per second. That's the meaning of hertz. That's what hertz measures. That's the meaning of frequency. How many times something happens per second? This is what your FM or AM dial. This is AM. Well, this is what a radio dial means. 102. What's a popular radio frequency? I'm just. What channel do you listen to? Does anyone listen to the FM radio anymore? It's all YouTube. Nobody has an FM radio. You listen? What channel do you listen? Station do you listen to? 106.1. That means the frequency of the radio waves, the core radio waves coming out of that, are 106.1 million cycles per second. Radio waves are fast. Hey, here we go. 1029. 102.9 means there are 102,900,000 wiggles per second in the radio frequency sine wave emitted from that radio station. Talk more about this next semester. Question? Yeah, thank you. Okay, so frequency is a very generic term. We will use frequency a billion times this and next semester. Period is an intimately related quantity. Period, which is traditionally called capital T, has nothing to do with grammar or menstruation. Not in physics, anyway. I should hope you know that the abbreviation for time is seconds. I want to emphasize, by the way, period capital T, lowercase t is used for any old time. The time to go halfway around a circle I would call lowercase t. The time for a full rotation would be capital T. That's period. So don't use period for half a cycle. Don't use period for a 13th of a cycle. Period means one full cycle, capital T. Period means how many S it takes for one happening. One thing to happen. One thing that repeats. One thing that repeats regularly. So we would never talk about the period of a lightning striking you. God willing, you're not being struck routinely. Ouch. So not just how many seconds for one thing to happen once, something that repeats. Anything that repeats, a full circle, a spin, a cycle of a radio wave, whatever. So period, cycles per second, frequency seconds per cycle. I hope that it will not be a big shock to you that you can calculate frequency as inverse period. Period is inverse frequency. I also hope that these two equations can be derived from each other and do not seem to be two things to memorize, but one. Cycles per second, seconds per cycle, they're just reciprocals of each other. Again, if you memorize physics as alphabet soup, you've got 4 things on the board right now, right? I claim if you know the meaning of these words and think about their meaning for a couple of minutes, you've got 1 thing to know. The combination of time with how things happen. That's 1 idea, can be described a couple of ways, and they're related in a couple of ways. Look for the pattern. Okay, that said, I have asked you not for frequency. I have not asked you for period. I've asked you for the speed. Nevertheless, I told you here that 0.13 revolutions per second, times per second, cycles per second, that is a frequency. What's the one and only equation you know for velocity in this chapter? Distance per time. All right, well, the distance we talked about, 2 pi r. The time is, bam, right there, inverse frequency. So I could put these together and say that speed is 2 pi r divided by, well, that's sort of silly to divide by inverse frequency. What happens when there's a fraction downstairs other than panic? You can multiply top and bottom by f. And you get 2 pi FR or 2 pi RF equivalently. That shouldn't be up. Okay, I want to emphasize something here. Blah. I'm going to go back to the beginning. I'm going to emphasize, go away. I'm going to emphasize something here. Velocity equals 2 pi times the time something happens in 1 second times the distance it is from the center to the edge times per second distance, meters and inverse seconds, meters per second. If you just multiply F times R, you will get the right units. Frequency is inverse seconds, 1 over seconds. Turns is unitless, and R is meters. However, you will get the answer wrong guaranteed. Meters per second, meters inverse seconds doesn't make sense, doesn't multiply up. You must think about what these terms mean and know this equation. Well, actually, there's a simplification here. I define angular frequency as the angle per second, and I can interpret 2 pi as the ratio of angle to turns. Wait a second, 2 pi radians equals 1 turn. Radians per turn, turns per second. What's radians per turn times turns per second? It's radians per second? Radians per second, angle per time. What is that? What's angle per second? Angular frequency, angular speed, omega, angular velocity, if I give you a sign. Velocity equals r omega. Oh, hey, that's a nice simple equation. In this particular case, the fast way to do this, you don't need to calculate omega and then use it to calculate r, but I would like you to be able to calculate v, and I'm introducing a new equation, v equals r omega. Is it a new equation? Well, no, not really. It's a combination of what is circumference and what does angle per second mean. What is radius and what is angle per second? One more slide on this topic. I alluded to radians several times. Let's take a second to talk about this. Degrees, turns, rotations, revolutions, percent of cycles, these are all reasonable ways to talk about angle, but they're not the convention. The standard in physics is to use the radian. 1 radian is defined as 1 r, the angle is obtended by 1 r. Well, I'm just going to say it's 57.3-ish degrees. That's 180 over pi, 360 over 2 pi. So you need to know that number. It will come in very handy on homework, tests, quizzes, blah, blah, blah. 1 radian is 57.3 degrees. 2 pi radians and 1 complete revolution or circle or cycle or whatever, that's another important thing to know. 2 pi radians is 1 full, like 360 degrees is 1 full. Hopefully you know the 360 degrees is a full. Well, here's just another way of measuring angle. Okay, now there is a new formula I wish to give you, which actually is an old formula in disguise. If you measure angles in radians, then there's a gorgeous little relationship between length of a circle edge, some part of a circumference, and angle. It's just multiply r times theta. Wait a second. Length of a circle edge, length of an arc. Technically, this is called the arc length. Big shock. The arc length, isn't that just part of a circumference? What's the angle for a complete circle? No. Degrees. No, not degrees, in radians. 2 pi r. 2 pi. What happens if we plug in theta equals 2 pi? What do you get? Oh my sweet baby Jesus. Yeah, you see, if theta is 2 pi, if you go all the way around the circle, 2 pi r just reproduces the circumference formula. This is nothing but the circumference formula where I say part of the circumference and part of the angle go together. Any fraction of the full 2 pi r is the same fraction of the interior angle. This is maybe slightly, I don't want to use the word profound, that's overselling it. This is worth taking a second. Please turn to your comrades and discuss for a second, what the hell did Tucker say and why did he say it? What does it mean that S equals R theta is the circumference idea? All right, so there are a fair number of things we've talked about, but again, I'm begging you, I'm hoping, I am encouraging, I am pleading, I am strongly suggesting, if you look for the connections, there aren't 50 things I've introduced on these slides. I think I've introduced 4 ideas total and connected the ideas. It's a web, it's not a list. Talk to me about this connection here. S equals r theta, S equals r theta, length of a part of a circle circumference equals r times a part of a circle's interior angle. Question me about this. Length of an arc equals radius of the arc times angle measured in the best units, radians. Nobody, really not a single person wants to ask about this? Please, Jane. No, please, please ask. If you could think of a question, 5 other people have the same question, I swear. Radians, r times radians. Yeah. Yes. Exactly. Question in the back. When theta equals 2 pi, we have come all the way around. 2 pi is the angle of a full circle. Yeah. No, when theta equals 2 pi, this gives the circumference, but you can always use r times theta to find any part of a circle or a turn. Suppose you go 30 degrees, pi over 6 radians of a turn of a 5-meter radius. How could you find, half a second, how could you find the distance you have gone? Again, your angle is pi over 6, about half. Your radius is 5. How could you find the speed that you went? Multiply r times theta, 5 times, I'm sorry, what did I say? 5 and 0.5. So you're going 1/4 meter per second. 2.5 meters per second. Gene, pull it.
Are you saying that theta is 5 when it's the full rotation?
That's what I mean by a revolution and a radian. Yes, exactly. That's this point. 2 pi radians and 1 revolution, samey, samey. S is the distance around some wedge. The angle of the pi slice is theta. The S is the length of the crust. These are connected by the formula. Crust equals radius of the pi slice, the straight edge, one of the straight edges, times the angle of the wedge. Why must the angle be measured in radians? Because otherwise it doesn't work out. The circumference formula ain't 360 r, it's 2 pi r. That only works if one full circle is 2 pi. You want to go down a deeper dive? No, I'm not going to do that in class. If you want to go down a deeper dive, ask me after class, office hours, email, or whatever. Goes down to the meaning of radian, and its definition is why this works. But radius, r equals, s equals pi. Oh, for dog's sake, I can't speak. S equals r theta only works if theta is in radians. Yes. Other questions, please. Yeah. So many. Do I have problems that you use to practice this? I will put a couple on the homework. How's that sound? To measure specifically angle and arc length, or just angle? Wedge? Wedge? Okay. So one thing is, you don't have to wait for me to put it on. If you just Google, the term for S is arc length, one word. The length of the archy part, this is arc length, one word. Hell, even my nemesis Khan Academy will have problems that have graphics and whatever. You can find 100,000 problems on Khan Academy. You guys all know about the open source OpenStax book? I'm not sure that OpenStax includes a section on radians where you practice, but I'm pretty sure. Do you guys all know OpenStax? I should have mentioned this on the first day of class. OpenStax with an X because sexy. If you Google OpenStax college physics, or probably even OpenStax arc length, you'll get a free online textbook with 8,000 problems in it, exercises and questions that you can get lots of practice on. I will also include a problem or two, but you want lots of practice? It sounds like I don't want to have a 50 question homework. People would not be happy with that. But here are a couple of resources. Yeah. Good. Let's move on. I want to emphasize something here. If you trust me that distance around a crust equals radius of that pi slice times the angle of that pi slice, if you trust me that S equals r theta, arc length equals radius times radians, what happens if I divide both sides by time? What if I am moving along the crust? What is S over T? What does it mean? What must it mean? Speed, not angular. S is meters. S is meters. A distance, a length around the crust is circumference is meters. Meters along a path divided by the time to go along that path is speed, ordinary tangential speed. What is angle divided by time? Angular speed. So I could rewrite S over T as V and theta over T as omega. And sweet baby Jesus, I've just derived the formula from the previous slide. It's not a new formula. V equals R omega. is directly straight, flat out of, not straight out of Compton, straight out of S equals R theta. These are muy importante. And again, if you look for the connections, muy simplicio, very simple. Again, if you find the web rather than just a list. S equals R theta, V equals R omega, same equals same, just only connected with time. You must know what a radian is, how to convert between various forms. And that's it. That's really all that's here. Yes, exactly. That's what I'm talking. That's the sermon I'm preaching. Here, picture. Here's a slice of pie. Here's its crust. The size of the crust, the radius of the pie, and this interior angle, if you measure it in radians, not degrees, is this formula. S equals R theta. S equals R theta. S equals R theta. The crust equals the width of the pie times the angle of the pie if you measure in radians. Yes. The first one. 3.43 meters per second. Not 4.2, because that's the radius. That's not the full distance you travel around. Full distance you travel around is 2 pi times radius. It is not does not equal RF. V equals 2 pi RF. You just told me the equivalent of V equals R times F, but you don't move along a radius line. You move around the circle, not across the circle with the what's it. Do not divide radius. Do not divide radius by time.
No, like, is the formula V is equals to R times omega?
Yes, and omega isn't 0.13. Omega equals 2 pi times 0.13. So if we wanted to do that problem with this method, R is 4.2, but omega is not what I gave you. I gave you raw frequency, 0.13 revolutions per second, not radians per second. If you converted 0.13 into 2 pi times 0.13, then you've got 2 pi RF, which is the other way I showed to do it. It's all one thing. Good, 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 good. These questions are showing me that people are thinking about this problem, this issue. Okay, let's summarize. We've talked about a few things. We've only got 2 days to do this circular and rotational stuff. And this is important. You doctors, and I don't know if the optometrists, I think the optometrists need this. OAT includes physics, right? Okay, you doctors and optometrists, just because we're only spending 2 days on it doesn't mean that we're not, this isn't important for your life. Yeah. Yeah, the S equals R theta, and if I divide S equals R theta both sides by T, I get V equals R omega. What? V equals R theta is arc length. I promise you S equals R theta, S is arc length. I promise you yes. But if I divide arc length by time, and if I divide angle by time, I get the second equation, V equals R theta, R omega. You don't like that. You don't like that at all, do you? Divide the first by time on both sides, you get the second. That's all.
Yeah, but I think I understand what you're trying to say.
Good. Okay, so looky. Theme 1, here's the first theme I played to you in my Einundolier. The angle, which we can measure in 3 different ways, degrees, radians, 4 ways, degrees, radians, cycles, percent of a rotation, sure. I mean, any way you want to think about it, there is the idea of an angle. And the best way is, of course, the radian, because physicists are cool. If you say radians per second, the angle per unit of time, the revolutions per minute, or if you like, the beats per minute if you're a musician, that's all an idea of angular velocity. Cycles, not that's frequency, I'm sorry. Beats per minute and beats per minute is a frequency. Angular velocity is when we're talking about some measure of angle per time. Revolutions per second would be, or RPMs would be a equivalent to an angular velocity. And there is the definition, angle per second. Wait, that's just theta divided by t is omega. Velocity of the angle. That's theme 1. Do you see that this is one idea? If you know what angle is, God willing, you've seen angle before in your life, omega is new, but it's not weird. Okay, S equals R theta, V equals R omega. I motivated these a couple of different ways. Hopefully, at least one of the things that I said in the last 10, 15 minutes has made some kind of connection inside, because this is what you did, and well more than half of you got that 3.43 correctly. This is a different way to access that. If you know the circumference formula and you know what period is, that's all that's contained inside here. And really, it's the same equation, just one is with and one is without time. I want to emphasize again, you can't use degrees in S equals R theta. And then the last idea, actually what I presented second, I should have switched the order here. What I presented second is you need to know what period and frequency are, and the idea that period and frequency, you can find one by reciprocaling the other. Google form something, ask me a question. Google form C. C is for I want to cry. You want to cry. Someone wants to cry. Give me a cry for help. Ask me a question about one of these terms, not my weekend. Yeah. What? Which term? Ah, but if we're going in a straight line, do we have a radius? Do we have a radians per second if we're going in a straight line? What would it mean to have a radius of a straight line? We can talk about something that turns as it goes straight. We could talk about a wheel, a bicycle tire, whatever, rolling around. And then there is a very real interpretation of V, R, and omega. V is the speed of the rim of the bicycle. R is the radius of the bicycle tire. Omega is the radians per second of the turning of the bicycle tire, and that will give you the speed that the bicycle drives at. Yes?
And on top of question, why is omega what the way it does for Zach? I always remember omega being a different than that.
So capital omega is the horseshoe.
Yeah,
That's the capital letter. Lowercase omega is that.
that's what.
The Greeks had capital and lowercase versions too. Ancient Greeks. Yeah.
Question, when you said like 0.13 per second, revolutions per second is not the angular speed.
Correct.
Then if it is
I mean,
0.13,
it's not omega. It's F.
yeah, so it's frequency, right?
0.13 is frequency, F, but not omega. Oh, go on, keep going, keep going, keep going.
This person then with the understanding, then can we do like circumference into 13%, which will angle towards the angle?
Say that one more time.
We,
Talk about that as 0.13 as 13% of the full. Yeah, 13% of 2 pi is indeed the conversion. 13% times 2 pi radians per cycle is absolutely the radians. Yes. Yes. Radians per second.
Maybe I can first, for my simplicity, I can deal with the degrees and then convert it into the radians.
Yes. You could.
360 or
Yes.
give me the theta.
Yes.
How do I get the time?
If I tell you how many revolutions happen in 1 second, you know how many seconds it takes for one revolution. Inverse.
So, like 1 divided by
0.13.
0.1.
There are many ways to do this. I'm showing you my favorite, the way that I think helps you build a web of knowledge rather than just a list of equations. But yeah, there are many ways to do this. You are allowed to do any way that gives the correct answer. When you are in doubt, if I ask a question, what is the angular velocity, and don't specify units, if you tell me RPM, you'll be marked wrong. If I don't specify, always default to SI units, radians, radians per second, seconds, yada, yada. Okay, let's see and answer as many as I can. How do you find radians? If you know an angle in degrees, if you know an angle in turns, fractions of a turn, whatever, apply the formulas that I gave before. 2 pi is the number of radians in 1 turn. 2 pi is equivalent to 360 degrees. If you've got 5 degrees, multiply by the radians per degree. If you've got 5 radians and you want degrees, divide by the number of degrees per radian. It's just a conversion factor. Different ways of measuring the same thing, like centimeters to inches. You know that 2.54 should probably know 2.54 centimeters equals 1 inch. So do a unit conversion between them. Yeah. If I give you degrees and you want radians, convert. If you've got radians and don't want degrees, don't convert. Are there problems like this given to our SI as well as to practice? Sahu knows this left, right, and center. He can absolutely give you additional problems. I do not tell him what to do for everything. We discuss and he can come up with his own exercises for this. And he knows how I teach well enough to do that. So yes, go to the SI. In the equation S equals R theta, theta divided by time is omega. Yes, that's the meaning of omega. Angle per time. Theta divided by time is the meaning of omega. So S equals R omega, S equals R theta becomes V equals R omega. Can I go a bit further into S equals R theta? I think that I have done as much as the majority of the class can stand. I'm going to encourage the person who asked, can you go a bit further into S equals R theta to stick around, and I will discuss as much as you want. Do I think I can redo the previous problem using these equations and terms? Absolutely, positively. Oh, for God's sake, let's see if I can scroll. So I've got what I ended that slide with is defining V equals 2 pi FR is V equals R omega. Okay, so 0.13 isn't omega. 0.13 revolutions per second needs to be turned into 0.13 radians, some number of radians per second is how we measure omega. Radians per revolution times revolutions per second gives you radians per second. Oh, for God's sake, I can't words, I'm sorry. So this is 4 point dose times 2 pi times 0.13 radius. Radians conversion measure of frequency gives you plug and chug 4.3 if I recall correctly. 4.3, 3.4. 3.4, right? Wasn't it? That is the equation that I was deriving. That's where it comes from. Is there other things that could be derived from this? No, I've showed you a web of things. I keep using that word. I hope I'm not boring you. There are different things you can do with this, different ways you can apply this. You'll see some of them on the homework. But these core definitions and how they're relating to each other, there we go. Can we try another word problem? Yes, absolutely. You got 4 minutes. Here's a conversion problem. Google question D and E, respectively. This will not take long. Don't be fussy. You can do it. There was another question. If you asked omega equals theta over time, does this only work when theta is 2 pi? No. If you know any angular turn and the time it takes, angle per time is omega. You don't need to have a full circle. Omega is the slope of degrees versus time. Yes, slope is the ratio of changes. Delta theta over delta t is omega is slope. How do we use radians? Same way you use degrees, just it's a different way of doing the same darn thing. There are a couple other really good questions. If I didn't answer your question out loud, please see me after class. I'm fine with answering. Why is that off screen? Why is that off screen? That shouldn't be off screen. There we go. What's the SI unit of time? Default to seconds. Seconds, meters, kilograms, and the combinations thereof. That's what we use the entire year in here. And your chemistry teachers can go suck it. Centimeters are wimps. Guess that's more a chemistry lab thing, right?
Did you see the question I was going to ask you that had nothing to do with chemistry? I've been asking all my professors this today. If they're a Pokemon engineer, what type they be?
A Jigglypuff because the name is funny.
I thought you'd be electric type. You teach a lot of electric, like dynamics stuff.
Sure, but I don't know any electric Pokemons. Pokemon? Pokemon? Yes. Is that a Pokemon? I know all about Pikachu. He's red and yellow, right? Ask my son. He's got some very rare ones, he tells me. Ooh, a lot of correct answers. You make me happy. Okay. Here we go. How long to do something once? That's period. Period is seconds per cycle. If I give you RPM, ultimately that could be converted to rotations per minute. You could find the rotations in 1 second, just divide by 60. 7,200 rot per 1 second can be multiplied by not 60 minutes is 1 second. That's silly. 7,200 divided by 60 tells you the rotations per second. If you flippy that tells you, yes, 120, that tells you the seconds per rotation. So question E was 8 milliseconds, 0.008, 0.0083. And to find the radians per second, we convert rotations as well to radians. Instead of talking about rotations per second, cycles per second, times per second, we want to convert rotations. One rotation is equal to 2 pi radians. Multiply that up, you get 750 odd. Please review this. Do a problem. Do lots of problems. Wednesday is more. If you pack this into your brain, it will help. I love you. Bye.